Welcome to the Fantasy Engine Lab. Here, you won't find cutting-edge facilities or massive funding. All I have is a cheap desktop PC and an imagination that tends to run wild. So please watch with kind eyes. This time, I dreamed up a variable compression ratio engine with a movable liner. A gasoline engine works by compressing a mixture of air and fuel, then igniting it to create power. The higher the compression ratio, the better the energy conversion efficiency. But if it's too high, knocking occurs, which can damage the engine. The compression ratio shows how much the air inside the cylinder is compressed as the piston moves upward. It's basically a number that represents the change in volume, and it's fixed for each engine design. But in reality, the effective ratio depends on the intake air volume, so it's not always constant. There are two main reasons. The throttle opening changes depending on the engine load. The intake manifold length, the tuning design, affects how dense the intake air is at different engine speeds. To keep efficiency high, the engine needs to maintain the best compression ratio depending on the intake air volume. That's where a variable compression ratio (VCR) engine comes in. Different VCR designs have been proposed in the past, but for a long time, none became practical. In 2018, however, Nissan developed a VCR engine with a unique linkage system and succeeded in mass production. There are two basic approaches. 1. Change the piston stroke. 2. Change the size of the combustion chamber itself. Nissan's method belongs to the first approach. The idea we'll introduce here is the second one, changing the combustion chamber volume. Inside the engine, between the cylinder block and the piston, there's a cylindrical liner, or sleeve. Normally, it's used to prevent wear and help form the water jacket. But here's the new idea. Move the liner up and down to change the combustion chamber volume. Raise the liner's smaller combustion chamber higher compression ratio. Lower the liner larger chamber lower ratio and less knocking. Threads are cut on the outside of the liner and the inside of the cylinder block. By rotating the liner, it moves up and down like a screw. At the bottom of the liner, a ring gear is attached, which is rotated by a worm gear. This makes it possible to adjust the compression ratio even while the engine is running. Compared to traditional VCR systems with complex linkages, this design is simpler and could reduce the number of parts. Effects: 1. Achieving both high output and low fuel consumption. 2. Reduction of component count and cost due to simple structure, linkless type. Anticipated concerns. 1. Rotational resistance of the liner caused by combustion pressure. 2. Effects on combustion due to distorted combustion chamber shape. 3. Increase in noise, vibration, and wear due to independent liner movement. 4. Structural challenges related to sealing, lubrication, and cooling. Summary: this concept is a variable compression ratio engine structure that changes the combustion chamber volume by moving the liner up and down. At this stage, it is only a conceptual idea, but it holds potential for the future. The purpose of this video is to visually explain the basic structure in motion.